this video is going to go over decomposition reactions. So let me state first that there are various different types of specific decomposition reactions. There's sulfate decomposition, phosphate decomposition, peroxide decomposition. We're only going to cover 3 of them. So for our class, at least, if it's not one of these 3, you'll just write it as simple decomposition. The first one is binary decomposition, and binary decomposition is pretty easy. It's going to be when we start with a compound, and it's going to break into its 2 parts. These may be elements, or they may be compounds, maybe some polyatomics. Either way, it's going to be one thing that we start with, and it breaks down into 2 things. So an example of this would be if I have sodium chloride, and it breaks down into sodium, which is a solid, plus chlorine, which is a gas. And remember that chlorine is one of our diatomics. And so with this now, I need to balance because I have 2 chlorines in my products and only 1 in my reactants. And now I need a 2 in front of my sodium. And so now I'm balanced. For a chlorate decomposition, this is going to be when chlorate is involved. So for example, let's say that I have aluminum chlorate. The chlorate ion is the ClO3. And so, since aluminum's a +3 and chlorate is a -1, I'm going to need 3 chlorates to balance it out. If you don't remember how to balance formulas, then please see one of my previous videos. So now this is going to break down, but because it's a chlorate, it's going to break down into something specific. So we're going to have a metal, and it's going to be with our chlorate. So this just stands for metal, so random metal. And so what's going to happen is when my chlorate breaks down, it will always break down into the metal chloride plus oxygen gas. Now the metal chloride is an ionic compound, so it will form that crystal lattice and be a solid. Then all we need to do is balance it, but this is the format that it will always break down into. So for example, with my aluminum chlorate, I have aluminum chloride plus oxygen gas. Oxygen is a diatomic. Aluminum chloride is an ionic compound, so it's solid. So there's my basic formula. Now I just need to balance it. And so I notice that I have 6 oxygens on my reactant side and 2 oxygens on my product side. And so I'm going to go ahead and put, it would help if I could do math, wouldn't it? I'm sorry, I have 9 oxygens on my chlorate side, my reactant side, and I have 2 on my product side. There's no way for me to get that 2 to become a 9 by using whole numbers. We're not going to use decimals to balance in this class. And so I'm going to go ahead and I'm going to make this even because that just seems to be easier. So 3 times 3 is 9. Times 2 is going to be 18. So as far as my oxygens are concerned, I have 18 oxygens. And so now that means I will need to put a 9 out front because 9 times 2 is 18. Well, now I also need to balance my aluminum. I now have 2 aluminum, so I'm going to put a 2 out front. And that gives me 2 aluminum. I also have 2 times 3, which is 6 chlorines. But the nice thing is that since I put that 2 there, times the 3, that gives me 6 chlorines. So I'm balanced. The last specific one that we're going to go over is carbonate decomposition. And so carbonate is going to be when we have a metal. So again, M is our metal. A metal carbonate. Carbonate is CO3, and it's a -2 charge. And so when I do this, it's going to always break down into a metal oxide plus CO2 gas. My metal oxide will be a solid because it is still a crystal lattice structure. So for example, let's see, what do we want to do? Let's do magnesium. Oops. Yeah, we'll do magnesium. Magnesium carbonate. So my magnesium carbonate is going to break down into magnesium oxide. It's a ionic compound, so it's going to be solid, plus CO2 gas. And so now I need to balance. So when I look at this, I have 1 magnesium on my reactants, 1 magnesium on my products, 1 carbon in my reactants, 1 carbon in my products, and 3 oxygen in my reactants, and 3 oxygen in my products. So it's already balanced. Hopefully this helps you to understand these 3 specific decomposition reactions. If you found the video helpful, be sure to press like so that I know to make more and that these are worth my time. Hope this helped. Have an excellent rest of your day.